In this video, we are going to look at the function f of x equal to 3 to the minus x squared. And we are going to look at functions that are related to that function. Many functions, g of x of the type a times 3 to the minus x squared. So we're going to see what happens if I multiply the formula in f by some constant. So here a is going to be a constant. Okay, but before doing that, we're going to look at the graph of f just to see what it looks like. So maybe let's start with a table of values, because f is not part of our toolkit functions, or it's not related to our toolkit functions. So we're just going to graph it by sketching a few points. So maybe let's start with 0, 1, 2. And here, those are values of x. Those are values of f of x. Ultimately, those are values of y on the when we are going to graph, sketch the graph of f of x. So those are the y coordinates of our points. Replacing x by 0 gives us 3 to the minus 0 squared, which is 3 to the 0, which is 1. Replacing x by 1 gives us 3 to the minus 1 squared. Now this is 3 to the minus 1, and this is 1/3, or if you prefer, approximately 0.333. Replacing x by 2, get 3 to the minus 2 squared, so that's 3 to the minus 4. So 1 over 3 to the 4, that's really small actually. It's so as you can see, as I increase the value of x, the y values are getting smaller and smaller, so the function is decreasing. Now let's try minus 1. 3 to the minus 1 squared. Notice how I have to put minus 1 in brackets, because minus 1 is going to be raised to the power of 2, all of that. So that gives us 3 to the minus 1. And like, hey, I've seen this before. Those are the same value. And I'm thinking, oh, hang on, what kind of function gives me the same y values for values of x that are on either side of the y-axis, right? That 1 and minus 1, it's the same y values. That looks like an even function. And if we look at what happens at minus 2, is that the same thing? And yes, right? We're going to get minus 2 squared. We're going to get 3 to the minus 4. So 1 over 3 to the 4. Same value again. So is that a coincidence? No, it's not a coincidence. This is an even function, because f of x, which is 3 to the minus x squared, and f of minus x are the same, because if you replace x by minus x and you square it, you still get minus x squared. So same value here. So that's an even function. So I just know that I need to sketch a graph of the function on for positive values of x and just reflect that across the y-axis. So imagine this is 1, this is 1, 2, maybe 3. So at 1, f is at 0. At 0, f is at 1. At 1, we're at 1/3. At 2, we're almost at 0. We're almost, and at 3, we're even closer to 0. So this is a curve that looks like this. And it's symmetrical with respect to the y-axis. So this is f. Now let's consider some g. So where a is, let's say 2, so g is 2 times e to the minus x squared. So it's 2 times, not e, 3. So it's 2 times f of x. Okay, so a is 2 here. So how's the graph of g related to the graph of f? So again, let's create a table in order to draw or sketch the graph of g. For a value of 0, f of 0 is 1. Now g is going to be twice that. Maybe not minus 1. At plus 1, f is 3 to the minus 1. G is twice that. So in other words, it's going to be 2/3. So every time g is twice, the y coordinate is twice the value of the y coordinate for a point on the curve representing function f. So y coordinates of points on the graph of g are twice those on the graph of f. So for instance, at 0, I'm twice as high, I'd be here. At 1, I'm twice as high, I'd be there. At 2, I'm twice as high, I'd be here. So you can see that g would look like this. So what it creates is a vertical stretch of our curve. If instead a was equal to 1/2, everything would be half as high. So you'd have a curve that looks like this. So you'd have what's called so it doesn't go below the x-axis. So we'd have what's called a compression. So the graph of f can be either compressed or it can be stretched, depending on the value of a. And let's take a quick look at this in Desmos. So here, this is the graph of f. Notice how I entered the expression a 3 to the minus x squared on the left hand side, and a is right now 1. So that's why this is the graph of f. If I increase the value of a, notice how this creates a vertical stretch. If the value of a is less than 1, there's going to be a compression going on. If a is negative, well, if a is 0, maybe that's in kind of a boring case. Your function is going to be completely flat. Not sure if I can make it entirely 0. Kind of hard. But anyway, the curve is going to be exactly the x-axis. If I, right there. And if I make it negative, then what happens is that there's either a stretch or a compression depending on the magnitude of a, but there's also a reflection across the x-axis that's going to happen. So if you had points that were above the x-axis, now they're going to be found below the x-axis, and it's going to be the other way around if you have points that are that were initially below the x-axis on the graph of f. So you're going to have to stretch or complex and reflect at the same time if a is negative.